Okay, the power of a quotient. What does that mean? Well, let's get into the problem right away. Consider a problem like this. A, B, where A and B are simply numbers or integers raised to the power of 3. If we were to expand this out, this would mean A over B times A over B times A over B. Okay? And applying the power, the product rule at the top, that will give us A times A times A, which means A 1 plus 1 plus 1 over B 1 plus 1 plus 1. Why plus 1 plus 1? Because there are 3 B's, there are 3 A's. This gives us a solution of A to the third power and B to the third power. Okay, so what can we find a relationship from here to here? Notice that so long as the power here is 1, the one's inside of the bracket, just bring the outside power and put it there, outside power and put it there. That's it. In other words, you will take the power of the inside one times the outside power by themselves. Okay, so let's start with some problems. This will give us now a general rule. The general rule will be as follows. General rule. The general rule says that if we have two numbers a over b to the power of m, that gives us a m and b m. That's how it is summarized. So let's simplify each expression. Simplify each expression. So when we go to simplify each expression, what do we mean? It simply means that we will work this out to the simplest form we can. Consider now the problem x over y raised to the power of 3. Well, if we simplify this simply means take the top piece and the bottom piece separate. We have x to the third power, y to the third power. Okay, the power here is 1, the power here is 1, giving us now x to the third, y to the third, and that's it. That's the solution for that one there. Okay, so notice that the power here is 1 times 3, 3, 1 times 3, 3. Let's go with some other ones which are slightly different. Consider that we have now x to the fourth, y to the third. Okay, and we are going to raise this to the power of 5. Well, here we kind of redistribute them and we end up with x to the fourth raised to the power of 5 and y to the third raised to the power of 5. Now we will apply the power of a power property, which is the rule, the power here of a power property, meaning there's a base to a power raised to the next power. So this now gives us x 4 times 5, 20, and y 3 times 5, 15. Notice what happened here. We took the base and we said the power of that base times the power outside. We end up with 20. I want you people to show this step here so I could see where you're going. Okay, let's try our next one now. We have 3x to the fourth over 4y squared raised to the fourth power. We're going to kind of redistribute them again and we end up with 3x to the fourth raised to the fourth over 4y squared raised to the fourth power. Now here we have the power of a product property. Okay, this is the product, this is the power, so we call it the power of the product property. But remember, this is the power of a quotient because this is the division. So we could individualize all of them. We put 3 raised to the power of 4, x to the fourth raised to the power of 4. This x to the fourth is this 4 and this outside 4 is this 4 over this one here is 4 to the power of 4 y squared to the power of 4, giving us now 3 raised to the power of 4 is going to give us 81. X now 4 times 4 is going to give us 16 over 4 to the power of 4 is going to give us 256, and y squared, or y to the power of 2 times 4 is going to give us 8, and that's our solution. And the same thing applies for if this was a negative. So if this was a negative 3, notice it's a negative 3, which would be squared. So let's try them as negatives now. So consider that we have the problem as follows. We have the problem negative 2x to the third over y squared. This simply means that I'm going to take my negative 2 squared x to the third squared over y squared. This square here comes from this outside square. We keep each one of them individually, which now gives me, well, negative 2 times negative 2 is going to give me positive 4, and we end up with x now 3 times 2, 6 over y 2 times 2, 4, and therefore that's our solution. So notice we raised it to the power of 2, and since it was negative, that became positive.